Is this bad?
Yes.
Good. As we were saying, let us go back, please. Today we are talking about covalent bonding. But before going to covalent bonding, let us take a brief revision or a brief recall of our memory about what is bonding. We say bonding is the force of attraction that exists between an atom and another atom. When two atoms react, or when they come together, the force that holds those atoms together, we call it bonding. Now, there are various types of bondings. The first one, we talk of ionic or electroviolent bonding. An ionic or electroviolent bonding is the force of attraction that exists between a negatively charged and a positively charged ion. It can be a metal and a non-metal, more precisely. For example, the force of attraction that exists between sodium and chlorine to form sodium chloride, table salt. That type of force of attraction is what we call an electroviolent or an ionic bonding. And remember again, an atom is the smallest fundamental particle of an element that can take part in a chemical reaction. Now, today we are going to be looking at covalent bonding. We say covalent bonding is that type of bonding whereby two molecules or two atoms come together to join in order to form a molecule. And then these two atoms that come together, they share equal number of electrons in the atom's share. In an electroviolent bonding, it is when two atoms, one is having lesser electrons, another one needs the lesser electrons in order to complete its outermost share. For example, sodium and chlorine. Sodium has electronic configuration 281. Chlorine has electronic configuration 287. You see that for this sodium to be completed, chlorine, for this sodium to be completed, to have a completely free atomos share, this one electron is supposed to free. And for chlorine to have a complete atomos share here, is supposed to gain one electron. This is an electroviolent bonding, whereby sodium is going to lose its electron to chlorine, and chlorine is going to gain one electron in sodium. When sodium is going to lose one electron, it's going to have greater number of protons, thereby becoming a positively charged ion. Meanwhile, chlorine that's going to gain one electron is going to have less proton and more electrons, and it's going to become a negatively charged ion. This one is electroviolent bonding. Now, in covalent bonding, nobody is losing something and nobody is gaining something. In electroviolent bonding, what happens? Each molecule contributes something in order to form the bonding. For example, chlorine, a chlorine molecule is made up of two chlorine atoms. Look here. One chlorine molecule, Cl2, is made up of two chlorine atoms, whereby the electronic configuration for chlorine is 287. Meanwhile, the electronic configuration for chlorine is 287. What does that mean? This chlorine needs one electron, so that should be 8. This other one also needs one electron, so that should be 8. Now, how do the two of them combine together? This is an example of a covalent bonding. What happens? This is the electronic configuration for chlorine. Let us use the dot and cross diagram. For example, here also, here we use the dot. Good. Look at it very well. This is the electronic configuration for this chlorine atom and the electronic configuration for this other chlorine atom. Now, this chlorine atom, what we are attending here is the valence share, whereby it needs one electron to be completely filled. This one also needs one electron to be completely filled. What happens? The two of them join together. This chlorine donates one electron, and this one donates one electron, so that the atomos share is completely filled. Now, what's going to happen is that you are going to have this 1, 2, 3. This also we are going to have 1, 2, 3. This one is the dot and cross diagram. Here you have 1, 2, 1, 2, 1, 2. Now, this chlorine is going to donate one electron here. Is that clear? This one now 1, 2, 1. Since it has 8 electrons in the inner shell and 7 outside, here, 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 here. Here it is going to donate 1 electron here. Now, if you look at the combination, you are going to see that this outer shell has 1, 2, 3, 4, 5, 6, 7, 8 electrons. Meanwhile, this other one, it has 1, 2, 3, 4, 5, 6, 7, 8 electrons. Is that clear? Eh? Is that clear?
So we have to join this.
This is an example of a covalent bonding. If you take this example and bring it to electrocovalent bonding, it cannot work. So if you ask me that you have to join it, I will say yes, but you have to join it following the way it is being joined.
So we join it when it is 1770.
No. You join it when the elements or when the molecules or when the atoms are supposed to undergo a covalent bonding. Because this 17 here, in another way, is going to react with something else. You will not join. Okay, you don't join when it is 17, no. You join it when the elements or the atoms that are concerned inside that reaction are undergoing covalent bonding. When they are going on covalent bonding, the force of attraction between them is different. When they are going electrovalent bonding, the force of attraction between them is different. The question you should ask me is, how do you know which element or which atom is undergoing electrovalent bonding, meanwhile which one is going covalent bonding? You know this by studying. You know this by learning. When you learn them very well, you are going to know that this other molecule, the type of bonding that exists between them. Because if in my exam I come with a question, I say, okay, this, using the dot and the dot and cross diagram, describe the type of bonding that exists between two chlorine molecules. That one is simple. This is a chlorine atom and this is a chlorine atom. The two of them, the two chlorine atoms, going to form one chlorine molecule. This one you already know, so you do it. Now, if I say describe the force of attraction that exists between chlorine and sodium, that one you are the one to identify it now. Because you are supposed to know from here that sodium chloride, the force of attraction between them is covalent, electrovalent, please. Meanwhile, chlorine and chlorine, the force of attraction between them is covalent.
So it happens like this when the numbers that come, they cannot divide it equal. Like it is odd number, like 17, 15, or...
No, the rule is not based on the numbers. The rule is based on the elements themselves. The rule is not based on the electronic configuration. Because I'm going to give another one now, like nitrogen. What is the atomic number of nitrogen? If you start to count from the periodic table, nitrogen is which atomic number?